Hi, I am Ayu Aniesa. My metric number is 161935 and I am first year student from School of Physics. I am the scriptwriter of this group. Assalamualaikum and good day. I am Safiah binti Hairul Azman. My metric number is 163730. I am first year student from School of Physics. I am the presenter for this video.
Hi, Assalamualaikum. My name is Farah Hanan binti Sakariah with metric number 162792. I'm from the School of Physics and I'm the first year student. I am the editor for this video. Check it out.
A solenoid is an electromagnet formed from a wire that carries current. Electromagnets have magnetic fields created from the currents. The wire of a solenoid is often formed into a helical coil and a piece of metal such as iron is often inserted inside it. When a solenoid is bent into the shape of a circle or a donut, it is called a toroid. According to physics, toroids are valuable because, like all solenoids, they are inductors that can induce or cause currents to be created in nearby coils. It was invented in August 1831 by Michael Faraday. Toroids also have what is known as self-inductance, which is a type of resistance. Toroid resists or fights in changing to its own current. The strength of self-inductance depends on the number of coils and AC source. Moving on to concepts and principles of toroid coils. Toroid works as an inductor which boosts the frequency to appropriate levels. Inductors are electronic components that are passive so that they can store energy in the form of magnetic fields. A toroid turns and with those turns induces a higher frequency. When current is applied throughout the toroid inductor, then it can generate a magnetic field around it. To conclude, toroids are more economical and efficient than solenoids. Well, just because this product is more economical, it does not mean that it is better to use it all the time. There are advantages and disadvantages that need to be considered. However, they are more efficient at producing needed inductances. Other than that, since the magnetic field is confined to the inside, toroids and toroidal transformers can be placed near other electronic components without concerning about the unwanted inductive interactions. In addition, toroid inductors generate high inductance as the closed-loop core has a strong magnetic field and they emit very low electromagnetic interference. These are much quieter as compared to other typical inductors due to the lack of an air gap. As for toroid applications, toroid inductors are used in different industries. Toroids are used in telecommunication, medical devices, musical instruments, amplifiers, ballasts, electronic brakes, refrigeration, and nuclear fuels, and also conditioner equipment. The magnetic field inside a toroidal coil depends only on distance from the central axis and is proportional to winding density and current. There are on final observation about toroidal coils that says at no point in the derivation of the magnetic field did we need to consider the cross-sectional shape of the coil. Therefore, the magnetic field inside a toroidal coil does not depend on the cross-sectional shape of the coil. As a reminder, avoid using DIY or do-it-yourself toroid coil as there are risks that need to be faced, such as the first point is inductance. The number of turns and the wire gauge of the coil determine the inductance of the transformer, which is a measure of its ability to store electrical energy. The inductance of the transformer is a key factor in determining its performance, especially in applications that require a specific level of inductance. The second one is efficiency. The quality of the winding, including the tightness and consistency of the wire, affects the efficiency of the transformer. The inconsistency and losing the windings can result in electrical losses, reducing the overall efficiency of the transformer. The next point is magnetic core utilization. The winding also affects the utilization of the magnetic core, which is the heart of the transformer. The winding must be carefully designed to take full advantage of the core's magnetic properties to maximize the performance of the transformer. The next one is current handling capacity. The wire gauge and number of turns also determine the current handling capacity of the transformer, which is important in applications that require the transfer of high currents. The next one is heat dissipation. The winding also affects the ability of the transformer to dissipate heat, which is important in high power applications. To conclude from today's video, toroid coil can be very useful despite its advantages and disadvantages. Due to its advantageous nature, toroid coil is practical to use, albeit from security systems, power distribution equipment, automotive electronics, and also renewable energy inverter system all utilize toroid coils. That's all from us. Thank you for listening.